Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Middle Ground by Aaron Toller. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have index lines, where on a blue line, the digit in the nth position starting from the diamond indicates the position along the line where the digit n appears. So say this was one really long, well, let's go here. Say this was one long index line. Then you could have something like, say, 4 here, which indicates that in the 4th position must be a 1. Right? Because the digit 4 is in the 1st position, and it indicates along the line where the digit 1 appears, which is the 4th position. And we could have something like 6 here, which means that in the 6th position, there must be a 2. And then we could have 3 here and 5 here, and that would be valid, because 3 indicates that 3 is in the 3rd position, and 5 here indicates in the 5th position, indicates that 5 is in the 5th position. So that's an example of how index lines could work. We also have parity lines, where digits along a red line must alternate between odd and even. So say this was a parity line. If this were, say, a 2, this would have to be 1, 3, 5, 7, or 9. Because you'll alternate between odd and even digits. 2 is an even digit, so this next digit next to it must be an odd digit. So that's an example of how parity lines work. And we have melding, where each line in the grid can be divided into 2 segments, each with a different rule as indicated on the line's ends. Each segment spans at least 2 cells, and the 2 segments meet at the center of one cell to be determined by the solver. So that's why, yeah, this is interesting. So this starts as a parity line going here, but somewhere along the way, it's going to have to end it's going to have to end, and then a different segment starts, which is going to be a index line. And we have to determine that for each of the lines we have here. And each line is at least 2 cells. So these 2 are definitely parity lines. But it could actually be that these are 2 parity lines and the rest of this is an index line, right? Well, technically not, because an index line, you can't have repeats on an index line, specifically because, like, how do you essentially, if you have, like, a 1 in a certain position, say you had a 1 here and a 1 here, or say you had a 1 here and a 1 here. Those are both saying 2 and 4 have to be in the 1st position, which is obviously not going to be able to happen. But, anyways, we know the first 2 cells on the line have to be of the indicated type. So these 2 must be index lines, and these 2 must be parity. And then the 2 segments meet at the center of one cell. So it could actually be that that's where it meets here. Or this could be, it can meet here, right? We don't really know. So, but that's how this melding works. We also have quadruples, where a digit in a circle must appear in at least one of the cells surrounding that circle. So around this circle has to be a 3, a 5, a 6, or a 9 in one of the 4 cells. Or sorry, a 3, a 5, a 6, and a 9 must appear in a square, in a cell surrounding this quad. We have to have a 5 surrounding this quad. We have to have a 9 surrounding this quad, etc., etc. Accessibility note. Each line in the puzzle is a melded parity index line, and the index line begins at the end with the diamond. So, yeah, these are all the index line starts, and this is a parity line as a start. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's start with the quads where we have 4 digits. We know those 4 digits must appear around those quads. So we have 1, 2, 3, 5 here, 3, 5, 6, 9, 1, 2, 3, 7 here, and this is 1, 2, 4, 6. That means for the other digits, we know exactly what those digits have to be. It has to be 4, 5, 6, 8, 9 here. These digits have to be 1, 2, 4, 7, 8. These digits are 4, 6, 7, 8, 9. These digits are 3, 5, 7, 8, 9. Well, we know these two have to be opposite parities, and we only have one even digit here, so that has to be an 8, which eliminates 8 in the rest of the box, and we have a guaranteed 8 here, because we know this has to be a parity line for the first two. This 1, 2, 3, 4, 5, 6, 7, 8. So this index line is at most 8, so we cannot have a 9 there. But we know there's an 8 here, which means this can't be 8, which means where's 8 in box 9? It has to be one of these two. That eliminates 8 in the rest of the column. So where's 8 in box 3? It must be one of these two digits. We know 1, 2, 3, 4, 5, 6, 7, 8, 9 can only be where the index is. So these 4 have to definitely be parity, which means we have a guaranteed 8 there, which is an even number. So 8 has to be one of these two. This 8 eliminates 8 from the rest of this row. So this must be 8, and it has to be with an odd digit here. So this is 8 and an odd digit there, which means 2 and 4 cannot be here, which means 2 and 4 have to be here, which eliminates 2 and 4 in the rest of the column. So this cannot be 4. So this index line so far is at least 6 cells, because it has to reference the 6th cell here. We know where is 1 and 2 in this cage. So each index line has to have a 1 and a 2 as part of it, and they cannot. They have to be on the index portion of this. So where are 1 and 2 in row 9? They have to be in one of these 3 cells. But if we have a 1 or 2 here, we don't have a 1 or 2 for the rest of this index line, which would eliminate that as a possibility. So this has to be 1, 2 here as a pair. So therefore, this is indexing that one. We don't know about the parity, though. Remaining digits of... So column 9 does not have 3 or 5 available yet. So 3 and 5 have to be in this set here. In 3 in row 1 has to be one of those 3 digits. 1 and 2 in column 1 have to be one of these 2 digits. So on the index line, we still need a 1 or 2 available. So 1 has to be in the 4th, the 5th, the 6th, or the 8th position. Well, it can't be in the 8th position because that can't be a 1. So this can't be 8, which means where is 8 in box 1? It has to be here. So that's 8. 1 has to be in the 4th, the 5th, and the 6th position. So we have a guaranteed 1 here, which means 1 cannot be anywhere else on this index line. 2 can be in the 2nd, 3rd, or 7th position, but it can't be actually in the 3rd position, because if it's in the 3rd position, it would have to be here, but we know the 1 or 2 has to be there. So 2 has to be in the 2nd position, 3, 4, 5, 6, or 7th. So we have a guaranteed 2 here, or a guaranteed 2 here, which eliminates 2 in the cells that see them, which would be both of these, and both of these. So we have a guaranteed 2 in one of those two cells. We have a guaranteed in one of those two cells. Interesting. So at least 4 of these cells have to be index lines because this references at least a fourth cell. This must be at least 6. So let's color in the ones that we... Actually, let's do it this way. We know these 4 have to be index. We know these 6 have to be index. We know these 2 have to be index. We know these 2 have to be parity. We know obviously those 2 are parity, and these 4 have to be parity because we have 6, 7, up to 8 and 9. Okay, 5 cannot appear here, so we have a guaranteed 5 in one of those two cells. 4 has to be here, because it cannot be here in box 9. So this has to be... Remaining digits... Oh, this can't be 1 because of the 1-2 pair in the box. So this has to be 4 or 5. That's referencing. Which means 1 has to be one of these 2 digits here. Okay. So 1 can be in... Cannot be in the 6th position. Has to be 7th or 9th. And it cannot be 7th because this can't be a 1 surrounding this quad. So therefore, this must be a full index line, and this has to be 1, which forces this to be 9 here. That eliminates 9 in the rest of the box. This can't be 1 anymore. This can't be 1, so this is 7, 8 as a pair. So this is 7, 1, which makes that an 8, which makes that a 7. And 9 can no longer be on this index line. 1 can no longer be on this index line. 2 can be in the 2nd, 3rd, or 5th position. We have a 2, 3, 5, 6 quadruplet on this index line. That leaves the remaining digits as 4, 7, 8. 2 obviously cannot be in the 5th position. 3 can't be in the 5th position, so this is a 2, 3 pair. That eliminates 2 and 3 in the rest of the box, so it's a 1, 5 pair. That eliminates 3 in the rest of the row. So that means 7 and 8 has to be in the 5th and 6th position. So this is 7 and 8, which means this can't be 7 or 8. It's 4, which indicates 4 is in the 4th position. Okay, this 5, 6 pair eliminates 5, 6 in the rest of the box. This 7 eliminates 7 in the rest of the column. Sorry, in the rest of the box. So this is 2, 4. This must be an even digit because we have an odd digit there. So this has to be 2, can't be 4. It's 6 or 8. Okay, we have 2 and 4 here. So we have a guaranteed 8 here. That means this is 3 and 5 with 6 or 7. 5 cannot be surrounding... 5 in this quad has to be in this box has to be surrounding this quad. 9 has to be surrounding one of these. It cannot be here. If this is definitely on the index line, and we can only reference 8 cells on the index line. So this cannot be 9, which means one of these two was a 9. But if this were 9, this would have to be 1. And that doesn't work. Because if we have 9 here, and this is 1, obviously this cannot be the center where they meld. Because 9 can never be on the index line. But then 1 and 9, then this would have to be where it melds. But the problem is 1 and 9 are the same parity. They are both odd. So this can't be 9, which means 9 has to be there. Okay. 9 eliminates 9 in the rest of row 9. So that means we have a guaranteed 9 here. That eliminates 9 here. So we know 9 has to be one of those two. We know 8 has to be one of these 3 digits here. Remaining digits of box 5, we have what? 1, 2, 3, 5, 6 left. Obviously, 1 has to be on this part here to match this index line. Um, 7 eliminates 7 here, so this is 4, 6. These have to be an odd even pair here. This is 1, 2, 3, 5, or 6, which means 4 has to be in those positions. So 4 can be in the first position, cannot be in the second. Could be in third, cannot be in fifth. And could be in sixth, technically. 3 cannot be in first or second, obviously. Could be in the third position, could be in the fourth position. Could be in the fifth, sixth, seventh, eighth. Okay. So we have a guaranteed 9 here, so 9 cannot be here or here. So 9 has to be one of these 3 cells there. Can we have 3 digits be here for the index line? That would mean it has to be 3, 4, and 5. No, the answer is no. So if we had all 3 of these be the index line, these would have to be 3, 4, 5. And then we'd have 7 digits in row 8, which would have to be from 1 through 6, which is not possible. You can't have 6 digits in 7 cells. So it cannot, this line cannot meld here, so this must be a parity line here. It could be just that's a parity line there, right? Can we have 3 and 4? Possibly. If we have 3 and 4, 4 would have to be here. This would be 3. The rest of this would have to be, so you'd have to have, 9 couldn't be here, so 9 would have to be there. You'd have an even digit here. You would have to have an odd digit here, and then an even there. So this would have to be 6. You'd have to have odd digit here, which has to be 6 or 7. Sorry, 7 or 8, which makes that 7, that's 8. So that looks okay-ish. Can we have odd even parities here? Let's just fill in the rest of box 9. We have 3 through 9. Obviously no 9 here because of 9 in the column. No 4 here because of 4 in the column. No 8 here, no 4 here because of 8 and 4 in the row. Um, so this could be 3, 4, 5, 6, 7, 8. So if this is an index line, where can 6 be? It could be 3, it could be 4, it could be 5, it could be 6, it could be 7. Okay. Mm, what else do we have? Hmm. Um, 2 can only be in the 2nd or 7th position, so this cannot be 2. Which means we have a guaranteed 2 there, but that doesn't really help us much. Oh, 8 cannot be here because of 8 in the column. So this has to be an 8 here. Which means 8 can never appear on this index line anymore if this is the index line. Because first of all, it's either 8 is here on the index line or we don't have it. This is not the index line isn't long enough to get support in 8. If this were a 7 as an index line, that would mean this has to be 3, which is impossible, so this can't be 7. Where is 8 then? 8 has to be one of these 2 digits. Okay. In column 3, uh, so this, if either this is a 1, if it's only a parity, or if it's index, it can't be 2 or 4. Sorry, it could be 2. It cannot be 4. It could be 6. So this can't be 4 at all. Um, so if this is parity only, this is 1. If this is index only, So this cannot be index or parity. Sorry, and parity. Because if it's index, so this has to be index or parity here. We don't know which. Um, so this is even. That would for if these were parity up to here, even, odd, even, odd, even. Let me think of that through again. Even, odd, even, odd, even. So then that would be 6 and that would be 4 if that were the case. This is the crux of the puzzle, I feel. Um, let's just try it. What happens if all of these are parity? Then we have 1 through 4 here, so this must be... Okay. Does that even work? No. Because this must be 1 through 4 in that instance. And 4 would indicate that's 1, but the parity would be even, odd, even, odd, even, which is not possible. Therefore, this cannot be parity. It has to be indexed at least to there. We could have parity up to here. So what happens if we have parity up to there? This is even. We have odd here. So that would be 1, which would make that 5. This would be 2. This would have to be 2. This would be 3, 4, or 5. 4. 1 would have to be here. This would be odd, or even. So this would be 1. No 1 here. It's 4, 6 as a pair. No 4, 6 in the rest of the column. This is 2, no 1 here. It's 3, 7. That 3, 7 eliminates 3, 7 here, so it's 5. This can't be 3 or 5, and it cannot be 6, so this is 4, which makes that 5. Where is 4 in column 1? It would have to be here. So that would make this 9. That would make that 6. We'd have to have 8 and 9 here, so 9 would have to be there. 8 would be there. 4 says that 3 has to be in the first position, or 4th position, and 1 has to be in the 5th. So that looks fine. No 5 here. No 5 here, so it's 3, 7, 9. 5 eliminates 5 here. No 3 here. It's 6 or 7. So far, that's okay. No more 3 here. This is even. So 4, 6, or 8. This is looking okay right now. This has to be a 1. 5 eliminates 5 here, so it's 6, which makes that 5. And we have a contradiction there. Okay. That was a long-winded way to show that contradiction, but okay. So, we know this has to be on the index line. And we could still have parity line there, though. So this cannot... it could be 8, technically, still. So what happens if we have index line there? So that's actually interesting. So we have 1 there, That makes us 5 and 1 there. 5 eliminates 5 here, so it's 6 and 5. 5 eliminates 5 there, so that's 4, which makes that a 1 for the index line. So that's fine. No 1 here. This is only 6 in size, so this cannot be 7. It's 2. 1 eliminates 1 here, so that's 2. No more 1 here. No more 4 here. 3 is either in 3rd or 5th position. Because this must be... can't be 4, so it has to be 6 for that index line to work. One thing we do know, actually, without doing that, is this can never be 8 here. Because if this were 8, the index line would have to go to 8 in size, but we already have an 8 on the index line if that's the case. So again, we know this can't be 8, but we're testing if this is index. So, if this is parity. If it melds there. So then this has to be 1, no 3, 5, or 7. 1 eliminates 1 here. It's 3, 7 as a pair. That means this can't be 3 or 7. 1 eliminates 1 here, so it's 5 and 1. That means this can't be 5. It's 6 and 5. That means this can't be 5. It's 4. No 4 here. It's 5, 6, and 9. 3 and 7 eliminates 3 and 7 here, so it's 2. Makes that a 1. 4 says that 1 has to be in the 4th position. This can't be 4 anymore. It's 6. So no 1, 6 here. It's 3 and 5. This can't be 3 because of 3, 7 pair in the column. So it's 5. And this can't be 3, 5, or 7. So that's a contradiction. Okay. Well, there you go. So this has to be part of the index line because we tried to make that the meld of the index line. Obviously, we can't meld there because then if this is part of the index line, 7 can only be in the 2nd or 6th position, but then these two are different parities. So this must be part of the index line here. So this is 7 has to be in the 2nd or 6th position, which it is. This is where 6 can be. 6 can be in 3, 4, 5, 6, or 7, which it can. And then 8 is in the 8th position, and it's parity there. Okay. Interesting. Unfortunately, that doesn't give us too much information. 5 can be... Yeah. Can 1 ever be here? I don't know what I'm... No, that's not that helpful, though. Do we have any counter examples here, if that will work? So say we had a 5 here, that makes that 4, which says 1 has to be in the 4th position. That also eliminates 4 from the rest of the index line. 5 eliminates 5 there, so that's 1, which makes that 5. 1 eliminates 1 here, so that's 1. And then we're 1 there. 1 can't be here. 5 can be in the 3rd, the 5th, or the 6th positions. Yeah. 4 can no longer be here. It's 5, 6, and 9 as a triplet. This is 2, 3, and 4 left there. I mean, it seems like it's fine. 5 can't be here. Um, hmm. Let's look at this here, I guess. If this is index line, it can only be 3. Mm, we know we have to have at least one digit here that's from 7, 8, or 9. That's the reason why this didn't work as all index lines there. Um, okay, what happens if this is 6? If this is 6, this is 2. That makes this 3. So no more 3s here. So then these are all parity line, which means this must be parity down to here because we can't have 3 available here. No 6, no 6, no 3. We have a guaranteed 8 here, which eliminates 8 in the rest of the box. So this is 8 there. That makes us 4 and 7. So where is 6 in row 9? It has to be here. That means this is odd. This can't be odd. It's even. Can't be even, so this has to be 8 here. This must be odd. We have a 5, 7, 9 triplet, which eliminates 5, 7, 9 in the rest of the row, so no 5 there. It's 1. That makes this 2 there. 1 eliminates 1 here, so it's 4. 2 would say 7 is in the second position, so that's 7, which makes that 2. No 7 here, no 3 here. So far, this is looking okay. No 6 here. 6 can't be in the 7th position. This can't be 6 or 7. Because 6 can't be in the 7th position anymore. 1 eliminates 1 here, so it's 5. 5 eliminates 5 here, so it's 6 and 5. So this I have to be even, so that would be 2 and that would be 1. 1 eliminates 1 here, so therefore 1 is there, so therefore 4 has to be there. 3 has to be in the 5th or 6th position. No 4, no 2 or 4. No 5 here. So 5 has to be one of these two digits. 7 eliminates 7 of the rest of this row here. 1, 3 as a pair eliminates 1, 3 here, so it's 5, which makes that 3. 4 cannot be on this index line, so this must be 3, which means 3 has to be in the 6th position, so this is 6, that's 5. This can't be 3, it's 7 or 9. We have to have 4 there, so this all seems to work, unfortunately. Shoot. Okay, I was hoping to reach a contradiction here. I'm not sure where to target, I guess. Hmm. What happens if this is 6? Okay, so 6 then, that means 7 has to be there. This can't be 7 anymore, so that's 2. No 6 here, this has to be 2 here. So this has to be a 1, 4 pair. That eliminates 1 and 4. The rest of the column. 6 eliminates 6 here and 6 here. No more 7 here because of 7 in the box. 6 cannot be on the index line anymore. 1 is in 4th or 5th. 3 is in 3, 4th, or 5th. 4 is in 1st or 3rd. Which means one of these is a 4, so this cannot be 4 there. 5 is in 1/3 or 5th position. Okay. 7 eliminates 7 here and 7 there. This is not helpful. 6 eliminates 6 here. Yeah, this isn't very helpful. Okay. So what happens if these are both index? So then this has to be a 4. That's 3. That means this can't be 4, 3. It's 2, which makes that 3. No 2 here, it's 6. No 6 or 4 here, it's 1. That makes that 2, that's 4. Therefore, 7 has to be in the 6th position. So that's 7. No more 6. That eliminates 7 on the rest of the index line. And 6. 3 and 7 eliminate 3 and 7 in the rest of the box. This is even. This must be odd. That must be even. So that's 6 there, which makes this 4 and 7. No 7 here. It's 3 and 5. That 3, 5 pair eliminates 3, 5 in the rest of the row. So 7 eliminates 7 there. So that's 9, which makes that 7. We do not have a 9 available in row 8. So that's where we reach the contradiction. Therefore, this can't be the melding point. We have to have at least that being parity there. We have 4 digits that are completely on the parity line. 4 cells, I should say, on the parity line, which means we have an odd-even split there. So this must be 2 odds and 1 even in the rest of the box. 2 odds and 1 even. So if this is index, it has to be 3. So let's make that index. If that's index, this is 3, which makes that 2 and 3. 2 can't be here, so that's 6. That leaves this at 2, so this is a 1-4 pair here left. 3 eliminates 3 in the rest of the box, obviously. This is 3, so this must be even there. Which makes this odd. Which makes that even. So this is 6 here. No 6 here. No 6 here. This must be 7 for the index to work, so that makes this 5. No 5 or 7 here. It's 4, 8, and 9. 5 eliminates 5 here, so it's 1, which eliminates 1 there, so it's 4. Which eliminates 4 there, so it's 8. This can't be 6 or 8, it's 7. That leaves that as 9. 6 eliminates 6 here, so this is 4 and 7, which leaves this as a 3-5 pair, which eliminates 3-5 in the rest of the box, so this has to be 7, but we have a 7 already there. So that's a contradiction. So therefore, this cannot be part of the index line. Okay. Which means this must be part of the index line here. I think we also proved that this can't be 3. Yeah, if one of these is 3, that makes this 2, which would make that 6, so that would be 7. Oh, specifically, these can't be 3. Because then that makes that even, which would be 6, so we'd have to have 4 and 7 there. This would be 3, 5 as a pair. Yeah, you don't have 7 anymore available here. Well, that's not true. Shit. Um... So what happens if this is 2? If this is 2, we know we have 2 odds here. This is even. This is 1. No 2 there. This must be odd, no 6, 8. This must be even, no 3, 4, no 3, 5, 7, 9. This is odd, no 4, 6, 8. This must be even, so that's 6. We'd have no 6 there. No 6 here, it's 4. Makes that 7. No 7 here, it's 3, 5 as a pair. 3, 5 as a pair eliminates 3, 5 there, so it's 7, 9. Six eliminates 6 in the rest of the box. 1 eliminates 1 here. So 1 has to be here, which means 4 has to be correct. A lot of going about. Anyways, that eliminates 4 in the rest of the index line. Four and 7 here. This can't be 7. This is 6, 8 as a pair. No 6 here. I mean, that seems like it works, unfortunately. One cannot be here, so 1 has to be there. That limits 1 from there. 4 eliminates 4 here, so that's 2 and 4. Oh, that's interesting. So this can't be 2 anymore. Where's the 2 in box 1? It has to be there, which means this can't be no more 2s there, so that's 6, which makes that 7. That means this can't be 7, so that's 9, which makes that 7. So no more 7s here. 6 eliminates 6 here. So this must be 2 there. Six eliminates 6 here, so that's 8, which eliminates 8 there, so it's 4. 4 eliminates 4 here, so it's 1 and 4. 1 eliminates 1 here, so it's 5 and 1. 5 eliminates 5 here, so it's 6 and 5. So that seems like it works okay. This has to be 6. 5 eliminates 5 here, so it's 3, which makes this 9, which makes that 2, which makes that 3. That seems to work fine. We have 5 and 8 remaining here. No 3 or 6 here. 6 can no longer be on this index line. Both these 3 and 5 are different, and they both see these cells. So this can't be 5, it's 2. This can't be 2, 3, or 5, it's 6. So we have 3 or 5 there. So that seems to work. No 3 here. Remaining digits of column 4 are 4, 5, and 8. 4 has to be here, 8 has to be there, 5 is there. So that seems to work fine. 3, 5 as a pair eliminates 3, 5 in the rest of the column. So this is 7, this is 1, this is 3. 3 eliminates 3 here, 8 eliminates 8 here, so it's 6, no 3 here, so it's 9 and 3. This is looking like the solution, to be blunt. 5 says that 8 has to be in the 5th position, so that's 8, which makes that 7. Yeah, that looks like it works. 8 eliminates 8 here, so it's 5 and 8. 5 eliminates 5 here, so it's 3, which makes that 5. 7 eliminates 7 here, so that's 3, which makes that 5 there. This can't be 5 or 3, it's 7, which makes that 5. Yeah, this is looking like the solution. Okay. Let's look. I guess let's look for another contradiction, which would be the other way around. Okay. So I guess then we would do this being 1. If this is 1, that means this has to be 2. This is 1. This has to be even, odd, even, odd. So this becomes 3, 5, 7 as a triplet. That means this can't be 7. This is 4, 6 as a pair. No 6 there. It's 7, 8. No 7 there. 5 has to be here for that to be satisfied, because 1 has to be in the 5th position, and that's saying 5 has to be in the 1st position. So no 5 there, no 5 here. This is odds even. Okay. 5 eliminates 5 here, so that's 6 and 5. 5 eliminates 5 here, so that's 1 and 5. 1 can't be here, 5 can't be here. No 5 there. 5 can't be here. Where's 5 in box 7? It has to be there. That means this can't be 5 here. Where's 5 in box 8? It must be there. So far, this is fine. We have a 2, 4, 6, 8 quadruplet in row 8, which eliminates 2, 4, 6, 8 in the rest of the row. So no 2 there, it's 3, which makes that 2. No 8 here, it's 7, which makes that 8. 7 and 3, eliminate 3 up, 7 and 3 there, so it's 9. So no 9 there, it's 3 or 7 there. This can't be 5, it's 4, 6, or 9 there. We have a 4, 6, 8 triplet in row 8, which eliminates 4, 6, 8 in the rest of the row, so this can't be 8, it's 2, which says 7 has to be in the 2nd position, so that's 7. No more 7 here, it's 1, 3 as a pair, that forces this to be 2. This can't be 3. No more 2 here. No more 7 on the line. So one of these two digits is a 3 to be in the 4th or 6th position. That eliminates 3 there, so it's 7, which makes that 3, which makes this 7. That means this can't be 3 here. No more 7 or 8 here. 2 eliminates 2 there. This is still working okay. 3 eliminates 3 here, so that's 9 and 3. 3 eliminates 3 here, so it's 1 and 3. No more 2 here, it's 6 and 8. We have a 6, 8 pair in column 6, which eliminates 6 and 8 in the rest of the column, so this can't be 8, it's 7. But now this index line doesn't work, because we have 7 saying that's in the 6th position, which means that 6 has to be in the 7th position, and that's a contradiction. So that's how we find the contradiction. I don't really like that as trying to. I don't know how else you can do that. You have to bifurcate there. People don't like bifurcating. I'm okay with it, but I don't know. This one didn't feel that great as a bifurcation. But anyways, so this can't be 1 here, which means we have to have a 1 here, so this must be 4. That eliminates 4 in the rest of this row. 4 eliminates 4 here, so that's 2 and 4. 2 eliminates 2 here, which means where's the 2 in box 1? It has to be there. That eliminates 2 in the rest of the index line, which means this can't be 2, it's 6. That's saying 7 has to be in the 6th position, so this is 7. And yeah, we go down this path. We cannot have 4 and 6 on the line anymore, so this is 3 and 5 as a pair. They both see V cells, so this becomes 2, 6 as a pair. No 2, 6 there. This is 3 and 5. 6 eliminates 6 there, so this is 1, 4 as a pair, which means this can't be 1, 4, or 6. It's 2. 6 eliminates 6 in the rest of the column. We have a 1, 3. This one eliminates 1 in the column. And we have a 1, 3, 5, 7 quadruplet in column 4, which eliminates 1, 3, 5, 7 in the rest of the column. So no 5 here, it's 9. That means this can't be 9 here. This can't be 9. And left here is 4 and 8. This can't be 4 because of 4 in the row, so this is 8 and 4. No more 6 or 7 on in box 8. 7 eliminates 7 here. 6 eliminates 6 there. 7 eliminates 7 there. 1 eliminates 1 here. This is 2, 6 as a pair. That eliminates 2 and 6 in the rest of the row. So no 6 there, no 2 there. We still don't actually know that this has to be 1 or 2. The 2 looked like it worked there, so I guess we should try the other way. Where is the 2, actually? 2 eliminates 2 here, so that's 3 and 2. 3 eliminates 3 here, so that's 9 and 3. 3 eliminates 3 there. Okay. This is interesting. We have 3 odd digits here. We have to have 9 in one of those two. That's fine. The remaining digits of column 2. 3, 5, 6, 7, 9, right? No 9 here because of 9 in the row. This can't be 3 or 5 because these have to be different 3 or 5s here, and they both see this cell. Remaining digits of row 1 are 2, 3, and 4. That eliminates 2 here. Okay. 3 cannot be here because of 3 in the row. 3 can't be here because of 3 in the row. This can't be 6 because of the 2, 6 pair in the row. So I guess we should try this out. Ugh. Anyways. If we have 2 here, this becomes 1. This must be even, and so must be 8. This must be odd. So no 4 or 8. This must be even. Cannot be 8, so it's 4. That makes this 1, which makes that 4. This must be odd, so it's 3 and 5. This forces this to be a 4, 6 pair. 8 eliminates 8 here, so that's 7, which means this can't be 6, it's 8. Okay. No more 4 or 8 here. It's 5, 6, or 9. That 5, 6, 1 eliminates 1 here, so that's 5, which makes that 1. 5 eliminates 5 here, so it's 6 and 5. That's saying 8 has to be in the 5th position, which it is. 6, 7 has to be in the 6th position, which it is. Okay, 6 eliminates 6 here, so it's 4 and 6. So far, that's looking okay. No 7 or 5 here. No 5 there. It's 3 or 9. 2 eliminates 2 here, so that's 6 and 2. So this can't be 2 or 4. It's 3. These can't be 2 here, so this must be 2 there, which makes that 4. 8 eliminates 8 here, so it's 6. 8 can't be here, so that's 8. 6 cannot be here. Where's 6 in box 8? It has to be here. And we have a contradiction. Yeah, I'm not a big fan of this bifurcation because it's just going down all the different distinct paths and then finding those contradictions, which is, I don't know. I'm okay with some of it, but to solve this, that's essentially what we're doing right now. And it's like, okay, I don't know. The fun stuff was basically all before, and now this is just basically tidying things up. But, yeah, it is what it is. So this cannot be 2, which means this is 1, which makes that 2. This can't be even. It's odd. This must be even. So it has to be 4, 8. That leaves this as odd, and this must be even, so it's 6, which makes this 4 and 7, which makes that 8 and 6. 8 eliminates 8 here, so it's 4. This is, again, odd. 4 eliminates 4 here, so that's 1, which eliminates 1 there, so it's 4. 1 eliminates 1 here, so it's 5 and 1. 5 eliminates 5 here, so it's 6 and 5. That's saying 7 has to be in the 6th position, so this is 7, which makes that 8. 5 eliminates 5 in the rest of the row, so this is 3 and 9. This has to be a 5-8 pair, but 8 can't be here because of 8 in the column, so it's 5 and 8 there. 5 eliminates 5 there, so it's 9. This can't be 3, 5, or 9. It's 7. No 7 here. No 6 here. This is 3, 5, 7 as a pair. 7 eliminates 7 here, so it's 3. 5 eliminates 5 here, so it's 3, which makes this 5. That's saying 5 has to be in the 3rd position, so that's 5. 5 can't be here, 3 can't be here, so it's 7, which makes that 5. No more 7 here because of 7 in the row. 3 can't be here because of 3 in the row, nor 7. If 5 eliminates 5 here, so this is 3, which makes this 5. 5 eliminates 5 here, so it's 6, which makes that 5. 5 eliminates 5 in the column, so this is 9. No 5 or 9 here. This has to be 3 or 6. 8 eliminates 8 here, so that's 6. 8 can't be here either because of 8 in the column, so 8 has to be there. 6 eliminates 6 here, so it's 2 and 6. This can't be 2 or 4 because of 2 or 4 in the column, so that's 3. No 3 or 4 here, it's 2. No 2 or 3 here, it's 4. 1 is the remaining digit in column 6, so that's 1, which makes that not 1, so it's 7. No 3 or 7 there, it's 1, which makes that a 3. 3 eliminates 3 here, so it's 6, which makes that a 7. Remaining digits of column 1 are 1, 2, and 3. And this can't be 2 or 3, so this is 1. This can't be 1 or 3, so this must be 2, which makes that a 3. Remaining digit of column 4 is a 5. Remaining digit of row 2 is a 7. Remaining digit of row 3 is a 9. Let's just fill out remaining digits. We have 1. 2 has to be here. 3 is done. 4 has to be here. 5 is done. 6 has to be here. 7's done. 8 has to be here, and that must make this 9. Yeah, this is fine. I really liked the melting. That was very cool. But then the problem is that this sort of degraded into basically just a lot of bifurcations. Of like, oh, well, try this. What happens if we meld there? The logic behind it is pretty sound. But, it's fine. I'm not as heavily against bifurcation as a lot of people. It wasn't quite as satisfying, though, for this one. I'm not really sure why. Maybe because there was a lot of really cool logic in before. But, yeah, we don't have that as we're doing the bifurcation. It's basically just try this. See if it leads to a contradiction, which it does. And then try this. See if that leads to a contradiction. Oh, wait. It seems like we're slowing down the solve path. Oh, okay, let's try another one. And then try another one. And then try another one. And you have to go down... I think part of it is you have to go down each of those paths to specifically lead to the contradiction. Because otherwise, you're not going to have the solve, right? You still have those other paths that you have to try out. So, I don't know. Still pretty cool. I like the idea of melding the whole segments and stuff like that, and how the index lines interacted. And the first probably 2/3 of the puzzle was really cool. And then the last third was just like, okay, let's try this, let's try this, let's try this. And wasn't quite as fun, but It is what it is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.